All right, let's get right into it. Today, we're talking about a technology that has completely changed how software gets built and run. We're talking about Docker, a platform that took a simple idea, the container, and used it to solve one of the biggest, most annoying headaches in the entire tech industry. Yes. Anyone who's ever written a line of code or worked on a software team has heard this dreaded phrase. It's the classic project killing problem, right? Something works perfectly on a developer's computer, but the second it moves anywhere else, it just breaks. This single sentence, this one excuse, is the exact chaos Docker was born to fix. So, what's really going on here? Well, this whole works on my machine thing is a massive bottleneck. The problem is all the tiny, invisible differences between environments. Maybe your laptop has a slightly different version of a library, or the server has a different operating system patch. These little things create a minefield of unpredictable bugs and can cause huge delays. And this is where Docker steps in and saves the day. It introduced a revolutionary concept, a standardized unit of software called a container. The whole idea was to create a single, reliable package that would act the exact same way no matter where you put it. Finally, a way to end the madness of software inconsistency. So, what is a container really? Just think of it like a perfect, self-contained little box for your application. It doesn't just hold your code, it holds everything that code needs to run. The specific runtime, the exact libraries, all the configuration files, literally everything. It's an all-in-one bundle that guarantees your app is always in its happy place, no matter what the outside world looks like. And this brings us to the two magic words of Docker, consistency and portability. Because everything is bundled up together, your application behaves the exact same way, whether it's on your laptop, a test server, or running in the cloud. Your app runs the same, everywhere. Period. That's the promise. Now, to really get why containers are such a big deal, we need to compare them to what came before, virtual machines, or VMs. You've probably heard of them. Both containers and VMs are about virtualization, but they go about it in completely different ways. Here's the best analogy I've ever heard for this. A virtual machine is like a whole house. It has its own foundation, its own plumbing, its own electrical, basically its own complete guest operating system. It's totally separate. Docker containers, on the other hand, are like apartments in a high-rise. They all share the building's core infrastructure, like the foundation and the main water lines, which in this case is the host operating system's kernel. But each apartment is its own secure, isolated living space. And that architectural difference has massive real-world consequences. Because containers just share the host kernel instead of needing a whole new operating system, they are unbelievably lightweight and fast. We're talking startup times measured in seconds or even milliseconds compared to minutes for a typical VM. And the size, a container can be just tens of megabytes, while a VM is often tens of gigabytes. That efficiency is what lets you run way more applications on the same hardware. It's a total game changer. Okay, so we get what a container is and why it's so much more efficient. But how do you actually, make one? Well, the process is actually surprisingly simple. It all starts with a simple text file and ends with your application running. It's this really elegant three-step process. First, you write a Docker file. Think of this as the blueprint. It's just a text file with simple commands, like, hey, start with a basic Linux system, install Python, and then copy my app's code inside. Second, you use that blueprint to build an image. This is the actual package, a read-only template of your application. And finally, step 3, you run that image, which spins up a container, the live running version of your app. So it's just blueprint, package, and application. That's it. And once you've built these perfect little images, what do you do with them? Well, you share them. This is where something called Docker Hub comes in. It's basically the GitHub for containers. It's this giant public library where developers can upload, download, and share millions of pre-built images, which means you don't always have to start from scratch. It really speeds things up. But Docker's story doesn't end with just running one container on your laptop. Oh no, it has exploded into this massive ecosystem that powers some of the biggest applications on the planet. Its impact now goes way beyond just fixing that original developer dilemma. See, when you start running applications at huge scale, you'll hear another name pop up all the time: Kubernetes. The relationship between them is actually super simple. Think of it this way. Docker packages the application. Kubernetes runs the fleet. Docker creates the container, and Kubernetes is the master system that manages running thousands, or even millions, of those containers across a ton of machines. And the business impact here is just staggering. This isn't just about making developers happy. Companies that switch to using containers report that they can release new code up to 7 times more often. Just think about that for a second. That means getting new features to customers faster, getting feedback faster, and just generally innovating at a speed your competitors can't match. And Docker is not sitting still. It's evolving to become the absolute foundation for the next huge wave in tech, artificial intelligence. It's quickly becoming the standard way to package up and run AI agents. And they're building new tools to make it super easy for developers to test huge language models and securely give them access to the tools they need. Which brings us to a really cool final thought. The container started as just a simple box to make sure things ran consistently. But today, that box is the vehicle for everything, from tiny websites to giant global applications, and now to intelligent AI agents. It really makes you wonder, as this technology keeps pushing forward, what incredible new things are we going to build inside the next container?